So now that we've seen how to compute the sum of all the squared errors and also the average error for the whole model, we can also calculate the percent error for a specific data point. And we do that by looking at the actual minus the predicted, so the error in the numerator, divided by the actual, and then we multiply that by 100% to get the percent error. So if we want to find the percent error for x equals 63 and x equals 75 for data set 1, right, well then we need to know what the predicted and actual values were. So if we go back to our list, this is what's nice about creating those individual lists. I'm going to go to List or Stat Edit, and I'm going to scroll back over. If I put L1, L2, and L3 on the same screen, I can see, well, there's my x value for 63. There's the actual x value, and there is the predicted x value. So I'm going to write this down. So for x equals 63, the percent error is going to be the actual value of 127 minus the predicted value of 120.07 divided by the actual value of 127, and then we're going to multiply that by 100%. I'm also going to go ahead and fill in, and then we'll use our calculator to calculate these. So for 75, the actual y value was 208. The predicted y value was 197.03 over the actual value times 100%. So now let's see what we get when we look in our calculator. So I'm going to do second quit to get out of this. So for the first one, you've got to make sure you're putting parentheses around this numerator, or else it's only going to divide the second number by the 127. So 127 minus 120.07 divided by 127, and then we're going to multiply by 100. And so I get a 5, and I'm going out 2 decimal places, 5.46%. Now we're going to figure out the percent error for when x is 75. So parentheses 208 minus 197.03, close parentheses, divide by 208 times 100. And I get 5.27%. So these both came out to be positive, so we know that the model was under predicting, right? And we get an error of 5.46% and 5.27% respectively.